In this video, we'll be looking at section 2.8. I'm going to split 2.8 into two parts. We'll call this 2.8.1. And the title of it will be Literal Equations. My essential question will be, how do I solve for a variable when there are other variables in the equation? How do I solve for a variable when there are other variables in the equation? So first I want to go over some terminology. And the terminology is going to just be this statement. If I say solving for x, what that means is solving for x means to have x all by itself on one side of the equal sign and everything else on the other. And we'll do this using our steps for solving equations. So solving for x means to have x all by itself on one side of the equal sign and everything else on the other. We could say solving for q, solving for r. Doesn't really matter what variable we put here, but when we see solving for r, that means we want to get r by itself. So just be mindful of that because we're going to be using those words. So let's do an example where we solve for x. So what I'm going to do is I'm going to put two equations side by side, one that we're comfortable with solving and one where the kind of like the new idea that we're presenting today. So let's do this side where x is the only variable, and on this side we'll have x with other variables. So I have on one side, this left-hand side will be where I have a normal equation that we're kind of more comfortable with, and over here is kind of the new material. I'm going to do this step by step on both sides. So I'll do one step on the left-hand side, and then I'll do kind of the similar step on the right-hand side. So please don't go ahead and just solve the left-hand side. Watch how they're very the same as we do it step by step from one side to the other. So first I'm going to write both equations, and they'll look quite similar. I'll have 3x plus 4 is equal to 13. And then on my right-hand side, I'm going to use 3x plus 4y equals r. So we're looking quite similar. I both have 3x's. We're adding something to that 3x, and then it equals something. So on my left-hand side, we'll draw our lines for organization. And on my left-hand side, I'm going to follow my steps where I subtract. I'm doing addition or subtraction first. So I'm going to subtract 4 from both sides first. So I cancel that out. 3x is left over here, and then I do 13 minus 4 is 9. Bringing down my equal sign, and I have 3x equals 9. Now on my right-hand side, I'm going to follow the same step, but instead of subtracting 4 from both sides, I'm going to subtract 4y. Because my goal is to get that x all by itself. So if I'm trying to get x by itself, then I need to get rid of not just the 4, but the whole 4y. So if I'm adding 4y, then I can subtract 4y. These will cancel. I'm going to bring my 3x down, bring my equal sign down. And on this side now, I can't combine these. This is an r and this is a negative 4y. These are not like terms. So I'll have r minus 4y. So the steps were quite similar. I had to get rid of an addition, so I used subtraction. I had to get rid of addition, so I used subtraction. Now I need to get rid of multiplication, so I'm going to use division. On my left-hand side, I just divide both sides by 3. 3's cancel. Bring my x and my equal sign down. Simplifying 9 divided by 3, and we get 3. On my right-hand side, I'm going to do the same thing. I'm going to divide by 3. But I need to divide the whole thing by 3. So I'm going to do like that. My 3's cancel. I can't simplify this. So I'm going to just have x equals r minus 4y divided by 3. That's my answer. So we're following the same steps. It's just that we can't combine a lot of things because they're not like terms. R and y's are different. This constant that I'm dividing by is different. So that's how we're going to solve these little equations. So let's do some more examples. And I'm going to flip over to the back now. So what we might see is some vocabulary that looks like this in our instructions where it says solve for the indicated variable. So all that means is I'm going to see an equation, and then it's going to tell me what variable to solve for. So let's say I had 28 equals t times r plus 4. On this left-hand side, when I do an example, I want you to we're going to recopy the problem so we can see how it starts, and then we'll see our steps. When you do it on your own, you don't have to recopy the problem. You can just start working on the original problem. So I'm going to recopy the problems, then we can see how the steps kind of unfold. Let me tell you what variable we're solving for. So we're solving for t. So the variable we are solving for is this one right here. So we're going to solve for t, which is this one right here. Now this one is pretty straightforward if we think about it. I'm trying to get t by itself. Well, to do so, what's happening between the t and this r plus 4? Well, if I think about this whole thing as its own piece, I'm just saying t times something. So if I'm doing t times something, I can just go t divided by something. So I'm just going to go straight to it, and I'm going to divide both sides by that something. I'm going to divide by that r plus 4. Do the same thing to this side. Now what happens is these cancel out. R plus 4 divided by r plus 4 cancels, and then I'm left with that t all by itself. And that was my goal, solve for t. And then I just really just copy down what happened over here. I can't simplify any of this, so I have 28 over r plus 4. Do not simplify the 28 and the 4. This addition is kind of what's slowing us down. This is division, and then when you try to use, you're kind of breaking a rule when you simplify division without taking care of the addition. So do not simplify that. This is our final answer. T equals 28 over r plus 4. So I'd like you to try a similar one. We're going to have Q times 3 plus W equals 17, and I want you to solve for Q. So solving for the indicated variable, and we're going to solve for Q. So go ahead and pause right here and try this one on your own. Okay, so if we took a chance to try this one on your own, so we're going to draw our line down the middle. And then I'm just trying to get Q by itself, so I'm trying to get this variable by itself. And I'm multiplying Q times 3 plus W, so I'm just going to divide by 3 plus W. Do the same thing to both sides, and I'll get Q equals 17 over 3 plus W. We're done. So some of these, if we use the correct tricks, can be quite quick. We can do them quite quickly. Now this next one is a little more complicated. So we're going to try to see if we can handle this. And this is what happens when we have variables on both sides of our equal sign. So if I'm solving for the same variable and it's on both sides of the equal sign, I have to kind of follow that rule. I need to get all the x's to one side and then all the other stuff to the other side. So say I'm looking at this equation right here. I have 3x minus 2y equals xz plus 5. So I'm going to recopy my problem so we know what we started with and then how it started changing. Draw my line for organization. My equal sign kind of disappeared on me. Okay, so our goal is to get, and we're solving for x. So we're solving for the x, and I have an x here, and I have an x here. So I need to get all my x's to one side, and then everything else to the other side. So let's see how we're going to do that. So the first thing I want to do is get all my x's to one side. So I'm going to subtract xz from both sides. So on my left-hand side, I'm going to have 3x minus 2y minus xz. And there's no like terms I can combine. This is x's and these are xz's. So it simply is this. These cancel, bring down my equal sign and my 5. Okay, so the question is, do I have all my x's? I'm solving for x. This is the original variable I'm solving for. Are they all on the same side of the equal sign? I've got x's right here, I got x's right here. So those x's are on the same side of the equal sign, and I have no x's over here, so I'm feeling pretty good about that. Next, I'm going to take all my others, all the stuff that's on this side that's not an x, and try to get it over here. So the first thing I want to do is move my 2y over. I'm going to use addition to do that. These two y's cancel. and I'll have my 3x minus xz is equal to, I cannot combine these. This is a constant, 5 by itself. This is y's, so I cannot combine these. So this will be 5 plus 2y. Now here's the trick. My problem is right now is I have x's attached to both of these. So I want to remind us of our distribution property. So over here, if I had 3 minus z and I had an x on the outside, I could distribute that x in, and I'd have 3x minus 3z. 3x minus xz. I just multiplied the x in. So what I want to point out is the fact that when I can do the opposite. I can go backwards. I can go this way and multiply in, or I can pull, since they both have an x, I can pull that x out front. So if this is the same as this, I can pull it out front and turn it back in to that. And this is called factoring. So I can factor that x out front. So I'm going to take this x, I'm going to factor it out. Since they both share an x, I can factor that x out, and I have x times 3 minus z is equal to 5 plus 2y. So that's all I did is I saw that the x was shared by both of them. I did reverse distribution. And now that we're looking at this idea right here is very similar to what we just did above. If I had q times 3 plus w, I could divide both sides by the 3 plus w, and I'd have q by itself. So in this one, if I have x times 3 minus z, I can divide both sides by the 3 minus z. And now I'll have x by itself. And then we find x equals 5 plus 2y over 3 minus z. So I want to just recap on this. We started off with our 3x minus 2y equals xz plus 5. So the first thing I want to do is get all my x's to the same side of the equal sign. So I subtracted xz from both sides. That canceled out these ones on the right-hand side, and it moved all my x's to my left-hand side. Now when I was looking at this, I had 3x minus 2y minus xz equals 5. So now I need to get rid of the y's because I only want x's on this side. So I added 2y to both sides to get rid of those y's. So then I had 5 plus 2y on my right-hand side, and since the y's were canceled, I had my 3x minus xz. Now I have this 3 and this z that I need to take care of, and when the trick I can do is called factoring, reverse distributing, where I'm going to pull this x out. Since they both have it, I can pull it out front, like so. And what's left behind is my 3 minus z. So we have 3 minus z with the x out front. And now that I have x times something, I can just divide by that something. So x times 3 minus z. So I can divide by 3 minus z. And I'll do the same thing to both sides, and then we're done. Let's do another one of these together. So we're going to have d plus 5c equals 3d minus 1. I'm going to solve for d. If you want right here, you're welcome to pause and try this one on your own. See if you can do it on your own. Otherwise, I'm going to walk through this one right now. So feel free to pause and try this one on your own. Okay, so I'm going to draw my line to help me organize. Let's make sure, make a little bit more space over here for my writing. So the first thing I want to do is get all my d's to one side. So I'm going to subtract 3d from both sides. Now in this problem, I can combine my like terms. So we're feeling pretty good about it. So I can do a d minus 3d is negative 2d plus 5c equals negative 1. Now I'll subtract 5c from both sides so I can get my d's by themselves, and I'll have negative 2d is equal to negative 1 minus 5c. Then we'll divide both sides by negative 2, and then I'll finally have d is equal to negative 1 minus 5c over negative 2. That's how we do that. So here's the problem to the left where I have to factor out the x, and here's a problem on the right where I can combine like terms. Okay, there's one more thing I want to show you today. And that's going to be our word problem. So we're going to need one more little bit of space for notes. And this is how we will be using literal equations. So we can use literal equations to help us solve like scenarios where we might be using a formula that we already know well. So let's say I want to find the height of a triangle if the area is 12 meters squared and the base is 6 meters. So I want to find the height of a triangle if the area is 12 meters squared and the base is 6 meters. So using literal equations can help us because we can solve for what we're looking for. I'm looking for the height. So I can solve for the height, and then I can just plug in my numbers. So we'll solve for the height. And step 2, plug in and simplify. So first what we need to do is have our area of our triangle formula. So the area of a triangle is equal to base times height divided by 2. So I'm going to take this equation and I'm going to solve for the height. I mean, I'm going to get the height all by itself. So to do that, I'm going to write my equation again. So I have area equals base times height divided by 2. We'll draw our line for organization, and we'll start solving. So the first thing I want to do is get rid of my division. So I'll multiply both sides by 2. That cancels, and now I have 2a equals base times height. Now I'm solving this for the height. This is my goal, trying to find the height. So now to get rid of this multiplication, we'll divide both sides by the b. That's a b. That is 6. So we're going to divide both sides by b. And when those cancel, I'll have h all by itself. So I can say 2a is equal to h, or more importantly, I can say, or 2a is equal to h, 2a over b is equal to h. So now I can just plug in what I'm told, and I already have h by itself. I don't have to do the math with the numbers in place. I can do all my math with my variables and then just plug in and solve. So now I'm going to plug in and simplify where I know that the area is 12, so I know a equals 12, and I know b, the base, is 6. So I can plug those numbers in, and then I'll solve. So I'll have 2 times 12 divided by my base. I'm going to have 2 times 12 divided by 6 is equal to the height. We simplify this, and we get 2 times 12 is 24. 24 divided by 6 is 4. So I can do 24 divided by 6 is 4, and that is equal to my h. And so that's how we can actually use literal equations to help us kind of move through these with less confusion on how to deal with the numbers. It's really important in science because sometimes our numbers aren't really friendly. 12 and 6 are nice and friendly, but what if I have like numbers that have 6 decimal places? I want to wait till the very end to plug those in and not be writing all those decimal numbers early on. So this is helpful when we're dealing with really strange numbers. So we identified the equation we're going to use. Area of a triangle is base times height divided by 2. Then I did the process solving for what the problem was asking for, solving for height. So I did this process, multiplying both sides by 2, dividing by the base, so I could have my height by itself. And then I plugged in my numbers because I'm trying to figure out what the height is. The problem told me that the area is 12, the base is 6, so I have a equals 12, b equals 6. I plugged those in, and then I simplified. And that's how we can use literal equations to help us solve, and how we can solve for variables even when there's other variables around. So thank you very much for watching this video, and I hope you have a great rest of your day.